Okay, so we're going to go over the intersection of a line and a line. And we have, as you can see, 4 different cases for when these events would happen in 3 space. The lines intersect at a single point is a pretty simple idea. We're going through 3 space, and we have 2 lines. They intersect at a point. Case 2 is the 2 lines are parallel and there's no intersection, and we're familiar with such an occurrence. We have 2 parallel lines, so they'll never intersect each other. Case 3 is there are 2 lines that are not parallel and do not intersect. They're called skew lines. So that's when you have a line going something like this, and it's hard to show in 3 space on a 2-dimensional thing. Another line like this. So think of it like it is above it almost. Okay? So they're not parallel, but they don't intersect each other either. So there's no intersection between them. And finally, case 4 is the 2 lines are parallel and coincident, which means you just have the same line, which is essentially a scalar multiple of the other. Okay, so those are our 4 cases. We have a question down here we're going to work with. The first thing we want to do is we want to check to make sure that our 2 lines aren't parallel. So we're going to put it through a test to see if they're parallel. It's exactly what we're going to do. We're going to be looking for the direction vector. So in line 1, they've already given us a direction vector. In line 2, they've given us in parametric form. So we can put it back into our vector form if we like. Okay? And in our vector form, we would have 4, 1, and 0 plus t, 13, negative 5, and 5. So this direction vector here, we have to compare to this one to make sure they're not scalar multiples of each other. And the easiest way would be we'll take negative 1 to negative 5. I need to multiply that by 5. So 2 by 5 would give us 10, which is not the case here. And 4 by 5 would give us 20, not the case here. So we know they're not parallel. So that eliminates case 2 and 4. Okay? If they are parallel, we just have to then check if they're scalar multiples of each other, which would make them coincident lines. And if not, then they have no points of intersection, and there's nothing to solve in this question. Okay? So, because they're not parallel, we're going to get into our next point. What we're going to do is we want them both to be in parametric form. So line 2 is already in that form. We're set up. We're going to change line 1 to that same style. So we'll have x is equal to 3 plus 4s, y is equal to 1 minus s, and z is equal to 5 plus 2s. I'm going to rewrite line 2 above it, just so they're all in my writing, so I'll be able to read it a little easier. X, our y value is already given to us, and the z value, 5t. Okay. What we're going to do from here is we're going to choose a pair, whether it's the answers for x, our parametric forms for y, or our parametric forms for z, and we're going to isolate variables. Because we have 2 equations and 2 variables, we can use them to solve for each of these parameters, or each of the variables. We'll take any pairing we like. To keep it simple, it's actually probably easiest to work with z if we look at it. It's already missing one of the other numbers, but we'll stick with x. Okay? So we could set them equal to each other, since x is equal to this value here, and x is also equal to this value here for a point of intersection. So of the idea that x is equal to x, which should be true if they intersect, then we have 4 plus 13t is equal to 3 plus 4s. Okay? And we'll isolate for one of the variables and then plug that back into the other one to solve. So in this one, I'm going to isolate, let's say, for the value 4. I move 3 over, we're going to get 4 subtract 3 is equal to 4s. Oh, and actually I want to keep the 13 on the other side. Sorry. The plus 13t is equal to 4s. Okay. So we then have 4s is equal to 1 plus 13t, which means our variable s is equal to quarter plus 13/4 t. So that doesn't quite give us a parameter for s, but what we're going to do is we're going to plug it back in to either of our equations here. And I think I'll plug it into this guy for s. Okay? So we'll take this equation here that x, oh no, sorry, we need one for t2. I'm getting confused. Give me a second. S equals t.
What if you just plug that 1 over 4 plus 13t over 4 back into the top?
Sorry. So now that we have a value of s, okay, we're going to take this s value and we're going to plug it in for another pairing, whether it's the y's or the z's. Okay? So let's set the y's up to be equal to each other. I'll do them in green. We have 1 subtract 5t is equal to 1 minus s. Okay? We can now replace s with what we had down here. So we have 1 subtract 5t is equal to 1 multiplied by 1/4 plus 13 over 4.
Multiplied by?
Well, minus. So think of it as like a -1. We'll have to distribute that negative into these two values. Okay? So 1 subtract 5t is equal to 1 minus 1/4 minus 13 over 4t. Okay. This is an ugly example. Let's get our like terms together. So we have our t's. We'll put them on the right side and all of our other numbers to the left. So we have 1 subtract 1 plus 1/4 is equal to 5t minus 13 over 4t, which is going to give us a 1/4 is equal to 20 minus 13 over 4. Let's just, whoa, not 7. Sorry. 4. And to get rid of all of our fractions here, we'll multiply the entire equation by 4, so we're then left with 1 is equal to 20t minus 13t, which is 1 is equal to 7t, which means t is now a 7th. Okay? So that gives us one of the parameters. Okay? Once we have this parameter, we're going to use it. We can use that value to go back into our x's, plug that in for t, and solve for our s parameter. So we have a t parameter, now we need to solve for an s parameter. I could put it into the z pairing. It doesn't make a difference, but we want to put it into one of the other two pairings. Okay, so once we use our y's, let's use our x's or our z's. And let's just go back to our x's since we already have that information written down. We know that when we pair them together, we have 4 plus 13t is equal to 3 plus 4s. Okay. We know that t is a 7th, so we'll replace 4 plus 13 times 1/7 is equal to 3 plus 4s. We'll get 4s by itself on one side, and we'll be left with 4 plus 13 over 7 minus 3, which gives us 1 plus. So let's go 7 over 7 plus 13 over 7 equals 4s. Whoa, I didn't write that out. 7 over 7 plus, what's that supposed to say? 13. There you go. I may say things so I don't write them sometimes. Gives us 20 over 7 4s. S is the parameter of 20 over 28, which is 10.
5 over 7.
5 over 7. Okay, so we now have two parameters. That's a lot of work just to get our two parameters, s and t. What we then do is go back into a parametric form for both of the lines, way up here. And we plug in our s and t parameter into both of the equations. When we do this, our x coordinates should be equal, our y coordinates should be equal, and our z coordinates should be equal. If they are equal, that means we have a line that intersects at a single point. When we plug these parameters in, if we don't get equal values for any of the three, that means we're dealing with skew lines that don't intersect. Okay? So I'm going to pause this here just to make the next part quicker. Okay, so we cleaned some stuff up. Now we're going to plug in our variables. So for the very first pairing, we'll deal with x. X is equal to 4 plus 13 times t, which is a 7th. And in the other example, x was equal to 3 plus 4s. Okay. So let's, oh, sorry, not s. Let's actually give our values here. S being 5 over 7. So we should get equivalent x's if we're intersecting at a single point. x is equal to 4 plus 13 sevenths, which is x is equal to 28 over 7, 13 over 7, 31, 41. 41 over 7. Let's see if we get that here. X is equal to 21 over 7 plus 20 over 7. We got 41 over 7. Okay, so those x coordinates work out, but it doesn't mean it's perfect. We do have to test the y's and the z's. So our y's, 1 minus 5t. 1 minus 5t. T was a seventh, we said. And the other one being 1 minus s. 1 minus s, which was 5 over 7. We'll test this out. Yeah, that's going to work. It's going to be 1 minus 5 over 7. We don't even have to finish it. We know those are identical. So both of our y's are going to be it. Now, if they want the actual coordinate, we'll obviously have to finish it, which would give us 2 over 7. Okay. So y is 2 over 7. Okay, so 2 of them worked out. Let's test out our z's. 5t and 5 plus 2s. 5t and 5 plus 2s, right? Our t was a seventh, which means z should be 5 over 7. And in this case, s was 5 sevenths, correct? Times 2 plus 5 equals z. This is going to give us 35 over 7 plus 10 over 7. Did this work out? No. So what relationship are these lines? Skew. So they waited right to the very end for us to figure it out. You may have figured it out right with the x's, but in this case, because of that one thing not being equal, and you should double check just to make sure you didn't make a mistake, but because those one things aren't equal, that means we're dealing with the third case here. We have two skew lines that don't intersect.